Hi everybody. So hopefully this will download all right for you guys and you'll be able to look at this and get an idea of what's going on, and then we will see each other again on Tuesday. All right, so we are starting on page 4 of the note packet, and on Tuesday we did start looking at some fractions for adding and subtracting that did not have the same denominator. And I wanted to look at another one of those to remind you before we move on to some of these ones that have a variable and also do not have the same denominator. So if we look at this one here, the 29/30 plus 7/10. Right, so they don't have the same denominator. And hopefully this is one where you can see that a common denominator would be 30. That would be an easy common denominator to do. Otherwise, you can go off to the side and say, all right, well, 10 is 2 times 5, and 30 is 2 times 5 times 3. So that LCD that we would like would be 2 times 5 times 3, or 30. And that's great because the first fraction is already in 30ths, so we can just leave that alone. And then we do need to change the 7/10 to get that to have a denominator of 30. 2 times 3, numerator and denominator. So that becomes 21/30, which will give us 50/30, which will reduce to 5/3, or 1 2/3. Now the one next to this one, we have a whole number and a fraction. So just remember that you can make the whole number have whatever denominator you want. So you might as well make it have the denominator of the other fraction you're concerned about. So we're going to be making 3/1 into something with a denominator of 9. So if we multiply by 9, numerator and denominator, you'd get 27/9. So this would be minus 27/9, or adding the opposite. So it'll be negative 16/9, or 1 and what, 7, negative 1 7/9. Now there are a couple different ones here, and we're going to look at the one with the z's over here. And this one is just, we're going from one denominator to the same denominator, but now squared. So thinking about these in terms of an LCD, well, z is just z, and z squared is just z squared. So you would grab that highest exponent for that factor, which is z squared. So we've got one fraction which is already in a good format, and we need to get the 11z, the 11 over z, to have z squared as the denominator. So here, each time we are going to multiply by z in the numerator and the denominator. So we would get 11z as the numerator here. So we have 11z over z squared. And that's going to end up being 11z plus negative 8 all over z squared. Or you could have it as 11z minus 8 all over z squared. Either one of those would be fine. You cannot simplify that numerator any further, so we're not going to worry about dividing out any common factors because we have to have it down to a single term in the numerator in order to do any simplifying that way. And the last one on this page, so we have 5t and 5. And this is one of those ones where people tend to forget. Okay, so you do need to multiply in order to get the denominator that we're looking for. So 5t, since one of them is 5 and the other is 5t, well, 5t is just going to be it's already really factored for you, so you can see that that would be the best least common denominator there. So 13 over 5t we can leave alone. And then we're going to look at the 4/5 and get that to have a denominator of 5t as well. So multiply by t, multiply by t. So this would have 4t over 5t. And it was negative because it was subtracted. So I'm going to change that there. And then now that I have a common denominator, I've done all the hard stuff. So the last bit here is, remember, we are going to keep that common denominator and just put those two terms together. So 13 minus 4t. You could also have 13 plus the opposite of 4t, or plus negative 4t. But we cannot get this to a single term in the numerator because it is not like terms. One has a t, one does not. And that means we can add them / subtract them, but we cannot simplify them to a single term, which means we can't do any simplifying with our denominator at this point. All right, and we're going to move on. And in section 4.7, we're going to just look a little bit more at some of those exponent situations with fractions, since we're going to be focusing on fractions a little bit more here. And it also just to, remind you guys about order of operations and how that might appear in a fractional situation. So really no new notes other than a reminder about our order of operations. And remember, part of the reason that I like to do this other one, the pandas eat mustard with dumplings and apples with spice, is because this part, the mustard and dumplings, so the multiplication and division, and this part, the apples with spice, or addition and subtraction, those two you have to be looking at the same time as you go from left to right. And that's part of the reason why I write my little checklist like this. But it may not be multiplication first. It might be division first. It's whichever of these you see first as you're scanning your problem from left to right. And then when you've finished all the multiplication division, you're going to do that same idea, but looking for addition or subtraction as we're moving from left to right. Okay. So basically, at this moment, we're going to look at some of our fraction situations with exponents. And this one is just the same as if we were, if we were squaring it. So 1/9 times 1/9, so 1 over 81, right? 1 times 1 for the new numerator, 9 times 9 for the new denominator. And this situation would be the same, and because we have the negative inside the parentheses, the whole thing is getting squared, so that will become positive. So this one will also be positive 1/81st. Now these next two will be different because it's an odd power. So you have to think about it a little bit differently. So here we're thinking about -1 times 4/3 cubed. And that -1, that's going to be further down in our list, right? It's after exponents with them. It's with multiplication and division. So we're going to leave that until we have a chance to do this. And we could also, this is a property we'll look at later, but I do want to illustrate to you right now, is that if I have a fraction in here, I can put that power on each part of that fraction. So I can change that to 4 cubed over 3 cubed. Still all multiplied by -1. So then it's going to be -1 times 64 over 27. So -64 over 27. And that's not going to have any common factors. It didn't have any common factors here. So it's not going to have any here because we're just repeating these same factors more than once. If we are looking at this with the parentheses and the negative on the inside, then we're thinking about it in this format, where I'm taking that entire chunk, the entire thing that's inside the parentheses, and I'm repeating that 3 times. I'm doing repeated multiplication with that 3 times. Now, it'll still end up negative because you still have an odd number of negative signs. It's just we have 3 of them here instead of 1. So we will still end up with negative 64 over 27. But the mechanism of how we get there is slightly different, and it's important for you guys to be able to understand the difference between those. Okay. Next one here. If you have a fraction and it is being taken to a power, I highly recommend seeing if you can divide out any factors in here first. And I can see that I have a 3 here, and I know that 6 is 3 times 2. So if I divide the 3 out, I'd end up with a 2 there. So inside my parentheses, I'd have negative 1 times 1 in the numerator and 2 times 5 in the denominator. So negative 1/10. And that whole thing is squared. And notice again, it's all inside the parentheses. So it's going to be like this situation up here with the negative 1/9, where we're thinking negative 1/10 times negative 1/10. And those negative signs are going to cancel out because we have an even number of them. They are going to cancel each other out, and we just end up with 1/100th. In the following problem, you'll notice we have some mixed numbers there. And the big thing with those is they must be changed to improper fractions before multiplying or dividing. And abbreviating those because I'm running out of space there. Before multiplying or dividing. So we have a little bit of work to do here. So the 7/9 we can leave on its own for the moment. And then remember that we'll have 2 whole units that are each broken into 6 pieces. So we'll say 2 times 6 is 12, plus 1 is 13, so 13/6 for that one. And for this one, thinking of 3 units that are each broken into 3 pieces, so 3 times 3 is 9, plus 1 more is going to give me 10/3. And remember, you always want to do this multiplication first because we are looking at our order of operations. And don't try to worry about the fact that we're going to need a common denominator eventually. Don't worry about that right now. Just do the multiplications and divisions first. Sometimes problems will work out where they will end up giving you a common denominator in places where you wouldn't necessarily expect it. So just make sure you're doing things in the proper order and you'll be on the right track. So 13 times 10, so that's 130. 6 times 3 is 18. And there is a common factor of 2 there. And hey, look, they're both even. And a common factor of 2. What is going to happen with my denominator if I divide out that 2? Well, that 7/9 will stay the same because I'm not doing anything with that. But this will become 65 over 9. And hey, they've got a common denominator here. Now, there may or may not be more that I could divide out here. But it's where I want it to be right now because I have a common denominator. I didn't have to work for it. So go ahead and add those 2 numerators. So 7 plus 65 is going to be 72 over 9. And then divide and see if you get a whole number there. You might. Let's see, you might remember this one is one of your multiples of 9. So we do end up getting a whole number and getting 8. So make sure that you're simplifying down to the lowest possible terms if possible. If there are any common factors, we do need to divide those out. All right, I will have to pause this for a second because the thing that I'm doing the videos on has a 15-minute limit, and this is a good spot to stop.